All right, here we go. We're going to talk about rational expressions and how you multiply and divide them. Multiplying and dividing, as always, go hand in hand. So, we know that rational expressions are basically just giant fractions. So let's take a look at this. 6x minus 12 over 4x squared. And we're going to multiply that by 3x cubed over 2x minus 4. All right, on a side note, what do we know about multiplying fractions? We know that if we're multiplying 2/3 times 4/5, when we multiply fractions, you multiply the top by the top and the bottom by the bottom. So this is the same, really, as 2 times 4 over 3 times 5, which is 8 over 15. So we're going to apply that principle to rational expressions. Top times top, bottom times the bottom. We're going to simplify. So if we look at this real carefully, let's start with 6x minus 12. How can we rewrite that? I'm going to factor out a 6, and that's going to leave me x minus 2. In the denominator, I've got this 4x squared. Not much I can do there, so I'm just going to write that, 4x squared. And if we multiply this all together, that means my 3x cubed is still here. And down here, so 3x cubed is taken care of, and 2x minus 4. Is there something I can factor there? I can factor out a 2 again, x minus 2. So remember, when we're trying to cancel things, we're looking for matching brackets. So this is all one big problem. So I can essentially rewrite this as 6 times x minus 2 times 3x cubed in the numerator. And in the denominator, I have 4x squared times 2 times x minus 2. And we could definitely multiply 6 times 3 here, 3x cubed. But when you're trying to simplify, multiplying it together doesn't make all that much sense. So let's see what's in the top and the bottom. I have an x minus 2. I can cancel those out. I have a 2 here that can cancel with the 6, and my 6 will become a 3. Now, you could have canceled the 4 with the 6. It doesn't matter, but you can only use everything one time. This x squared in the denominator, I can cancel with this x cubed and just have one x left. So, what does that leave me? In the top, I have 3 times 3 and an x. So I have 9x. And in the denominator, there's a 4. So 4. So there's our simplified, multiplied rational expression. These are tricky only because there's always multiple routes to take. We didn't even necessarily need to make this one big rational expression here. We could have left it as two separate ones being multiplied, as long as you were careful to cancel things that appear on the top and with the bottom. They can go across, right? Like the 6 and that 2, that's fine. But if you take this 6 over 4 and reduce it, then you can't do that with a 6 over 2. You can only do it once, if that makes sense. Okay, let's try another one. Let's try x plus 3 over x squared minus 4x plus 4 times x squared minus x minus 2 over x squared plus 4x plus 3. Okay, I see all of this. They're polynomials. The first thing I'm going to do is factor everything down to brackets, and I'm also going to combine it into one giant rational expression. So in the top, x plus 3, x plus 3. I'm going to put it in brackets. Over here, x squared minus x minus 2. What does that factor to? What two numbers multiply to negative 2 and add to negative 1? Well, negative 2 plus 1. In the denominator, x squared minus 4x plus 4. I'm going to factor that to x minus 2 times x minus 2. And the other side of the denominator, x squared plus 4x plus 3. So, So x plus 3 times x plus 1. Okay, so I've done two things. I've multiplied it. I know multiplying is going to put all my numerators in the top and all the denominators in the bottom. So I've done that piece. I've got everything in brackets factored. So now I'm going to go through and I'm going to find anything that is in the top and the bottom. And it has to be the entire bracket. So I have an x plus 3, gone. X plus 1, gone. X minus 2, x minus 2. What does that leave me? There's nothing left in the top. Just kidding. What's really there? A 1. In the denominator, all that's left is x minus 2. So 1 over x minus 2. Let's try another one. 3x minus 21 over x squared minus 3x minus 28 times 5x plus 20 over 2x plus 8. Again, the first thing we're going to do is factor. So 3x minus 21. I'm also going to draw myself one giant rational function. So 3x minus 21, I'm going to factor out a 3. I'm going to put this 3 in brackets because there's so much multiplying and it helps me visualize that I can only cancel out entire brackets. What's left? X minus 7. Okay, the next piece of the numerator, 5x plus 20. What can I factor out? A 5, again, I'm going to put it in brackets, times x plus 4. Denominator, x squared minus 3x minus 28. So what two numbers multiply to 28 and add, or negative 28 and add to negative 3? So that's going to be x minus 7 times x plus 4. Okay, and then our other side, 2x plus 8. I'm going to factor out a 2, and that leaves me x plus 4. Okay, what appears in the top and in the bottom? The 3 is only one 3. X plus 7, x plus 7. 5, nothing. X plus 4, x plus 4. X plus 4 appears twice in the denominator, but it's only once in the top. You can only use it one time. Okay, what's left in the top? I've got a 3 and a 5. They're multiplying. So 3 times 5 is 15. In the denominator, I have an x plus 4 times 2. So 2 times x plus 4. And that's, so then you're going to check, can 2 and 15 simplify? They can't. So we're going to leave that. You can alternatively write this by distributing that 2 back in if you'd like. You don't have to, but either of these will work as your final answer. Okay, now, dividing is the exact same thing. but with a trick. So when we divide fractions, think about this. When we say 2/3 divided by 1/6, we know that we do flip and switch, right? That's our trick. So that means we say 2/3, we switch this to multiplication and flip our second fraction upside down. And then we're right back to multiplying. So 2 times 6 is 12, 3 times 1 is 3, 12 divided by 3 is 4. So we're going to apply that to rational functions. We're going to take our second fraction, and we're going to flip it upside down, and we're going to multiply it. So let's take a look at this. What if we have x squared minus 5x minus 6 over 2x plus 6 divided by x squared minus 3x minus 4 over 4x plus 12. Remember, you can hit pause and try these on your own anytime you want. Okay, I'm going to leave my first one alone because I'm not going to do anything to the first side. I'm going to change to multiplication, and I'm going to switch this thing upside down. So 4x plus 12 is now in the top, and x squared minus 3x minus 4 is in the numerator. Then, now I'm going to factor it, and I'm going to make one giant rational function. I'm right back to where I was 2 minutes ago. So x squared minus 5x minus 6, that's going to factor to x minus 2 times x minus, nope, that's not what it's going to factor to. X minus 6 times x plus 1, and 4x minus 12, we're going to factor that. I'm just going to factor out of 4. I'm going to put it in brackets so I don't lose it. Times x plus 3. In the denominator, I've got 2x plus 6. I'm going to factor out a 2. And that leaves me x plus 3. And then over here, I've got my final one, x squared minus 3x minus 4. I'm going to factor that to x minus 4 times x plus 1. All right, now that everything's factored, I'm going to go back through. I'm going to see what cancels out. X minus 6, no. X plus 1, yep, get rid of that. X plus 3, yep, yep. Now I've got this 4, then the 2. Well, that'll simplify, get rid of the 2, and this becomes 4 divided by 2 is 2. So what's left in the top? X minus 6 times 2, so 2x minus 6. And in the denominator, all that's left is x minus 4. Again, you can distribute that 2 if you'd like, or not. Your call. And you're done. Okay, so let's recap really quick. You're going to multiply all the way across the numerator and the denominator. Simplify only brackets, and you can put whole numbers in brackets, that's fine, but you're also going to need to factor. Sorry, should have said that. So you're going to multiply, you're going to factor, you're going to simplify your brackets. To divide, you're going to flip and switch, and then go right back to where you started with multiplying. All right, cool.